Okay, hey guys, so it's day 8 of DSA learning, and yeah, we are on the track. And so sorry, if anyone is watching, yeah. So, irrespective, whenever you are, if you are ever watching this video, so thank you for like. Okay, so leave it. Let me start it again. Hi guys, so welcome to this channel, and it's day 8 of DSA learning, and yeah, we are making pretty much progress. So stay tuned, and we'll do something better. So if you wanted to learn DSA, just go for it. Don't wait for opportunities, or don't wait for a good time. Just jump into it, and start hustling and see the world reality. No one is going to come and rescue you. Just let me see once whether stream is working or not. Is it not working? What? Just give me a minute. I'm just checking whether stream is okay. Yeah. So we are on the track, and let me see once if. Okay. Hey guys. So I hope everything is going well. What? Just yeah. Give me a minute. So everything is all right, and yeah, our stream is working. I mean, it is working. So yeah, we are live now, and so very good night to everyone. And if you are sleeping, just have a good sleep. And if you are awake, you just woke up for a study or anything, then welcome. And yeah, let's begin TSA. So whenever you are going to watch, I know you. If you, in future, if anyone is watching, then all the best to you, bro. You came here just to learn DSA, but I'm also a learner. But yeah, I'll just suggest you wherever, like whatever level of DSA is your, or I mean, at whatever level you are right now, just keep on practicing, and one day you will succeed. And yeah, one more thing, just be positive and have a faith on yourself. Like me, for example, I'm just started, and I'm very excited to learn new topics. Not new topics, we are covering DSA. And before I jump to the take you forward website, and I start learning or maybe solving the problems related to array. And we are gonna practice, or we are gonna start the hard problems. We have covered our small, medium, and now it's time to learn the large problems, or you can say the big problems. And that's where interesting things comes. It's hard problems. Okay, nothing is hard until you are dedicated, you have perseverance, and you are persistent. So have faith on it. If you don't know, or you are unable to solve for, like, then just have faith and go through as much as time you can until you did not get something, until you are not grasping the root of it. Keep on practicing, bro. That is only the motto. If you see a string that is that is used to pull the water from a well, it can due to continuous or consistent uh, like every day it is following the same process, and it can make mark on the gear that is made up of stone. So you can think of a soft string can make a mark on a hard, or you can say stronger stone. So we are just like that. If you work hard and if you work dedicatedly, definitely you are going to also get something. Or you can, I won't say something is a broad and vague word. I'll say you whatever you wish to get. Just if your feelings, your imagination, and your dedication, hard work is towards the goal, then definitely you will get it. And I just draw this. There isn't any important thing. It's, yeah, if you see here, I wrote Chandigarh, Gurugram, reading aloud, or read out loud. So welcome to the channel, and yeah, let's begin, bro. So first problem is majority element. I don't know. Let's see, and let's see how to solve it. So we have a problem, and let me read out the problem first. So given an integer array nums of size n, okay, great, Actually, to be honest, even I am little scared from inner of my heart that these are hard problems. Will I be able to solve, or whether I won't be able to solve? And that is where you get nervous. So always remember, no, I'll solve. Okay, have a positive attitude. Have a positive attitude like me. Okay, we'll solve it. No problem. Given an integer array nums of size and return the majority element of the array. Okay, the majority element of an array is an element that appears more than n by 2 times in the array. The array is guaranteed to have a majority element. Okay, for example, you can say 7 0 0 1 7 7 2 7 7, and I feel like I already solved it. Like you are going to counter two elements. Whenever those are opposite, you are going to delete them. So one will be more than 7 times, so it will counter all the opposite numbers or all the numbers that are not similar. So it will counter all the elements except it will remain one more time. So that's kind of it's very difficult to I won't say it's that's why it will be easy for me to think about it, but that's why I'm telling you before I solved it and I remember it. I won't remember it, but yeah, I get it how to solve it. Maybe because of practice and all, but we are not going to follow that approach right now because the problem is we don't know or we need to learn patterns, and we will jump into patterns as soon as possible. But for the time being, first we will clear our foundations. For example, we are solving the arrays, then we'll go to DP. And if you know, there is a person who I really love her. My bad. So I really love his videos and the way he is teaching DP. So I'll say that bro is great for DP. I'll say it. I think that the name of the channel is Aditya Verma, and there's a quote written in his channel at the top of channel. You can see in the channel art, the person or people who can't remember something, there are high chances or there are chances you will repeat the same. So it's like if you are unable to read memorize something, yeah, if you can't remember something, then definitely you will repeat it. For example, let me take my example. Many times I watched same movies for multiple times. Okay, then I realized, oh, I think I already watched this movie, but I'm not sure if I watched it. But so that's why you will repeat the things. For example, if you aren't learning DSA in a proper way, maybe after 2 or 3 years, you will again repeat the same mistakes you are going to do again and again until you will finish it perfectly. Otherwise, you are going to learn the same syllabus, same exam, same trap, same things you are going to. So it's better if you do it in a perfect way for once and enjoy the enjoy the benefits of it forever. So that's why be positive and work hard. I'm not a motivational speaker. Even it is applicable to me. If bro, you are going to watch your own video in future, just remember, if you will make mistakes today, then it will reflect you tomorrow. So your tomorrow will be decided by today's actions. So whatever actions you are performing today, it will decide your tomorrow. Okay, great. So let's jump to the problem and let's solve it. So we have an example of, okay, let me change the zoom level to 700%, and we have 7 0 0 1 7 7 2 7 7. Great. So we have these numbers, and now we need to find out the majority element. And let me jump to the screen and I'll show you. Maybe let me note down another example. Okay, my bad. Okay, let's learn it from this example only. So the idea is simple. There are n by 2 greater than n by 2 elements where values will be same. Okay, I mean because the same element is repeated more than n by 2 times, means there will be less than n by 2 numbers where the values will be different. So can we say if we are going to go, let's say there are more than n by 2 numbers, and let's say these are nothing but n by 2 plus 1 there are numbers, and n by 2 minus 1, these are the numbers. It could be random numbers, okay, and these are same number, same x, let's say. So now the idea is simple. Whenever you are getting the same number, then you are going to add those numbers, okay. No, what I'm doing, bro? I forgot the algorithm. Okay, so idea is simple here. If you are getting 7, then if you are getting another number, say 0, then you will say 7 plus 0 0, you will make them 0. These are opposite number. Then you got 0, and you will look for another number 1. So it will be like 0 and 1 will be 0, or maybe you can say 0, and then you got two another numbers like 7 and 7. So you, these are the same numbers, so you will take out of these one, and then you are going to check another for another number, then you will get 2. So again you can say it is a opposite number, then you will simply subtract them, okay. I mean you will just make them 0. Yep, you will make them 0. So and then you got the 7 and you got the 7, so that's how you will do it. But I'm just I need few more clarification on it, how exactly we are dealing with this conditions. So we have number 1 1 1 2 1 and 2. So let me jump to this draw board, or let me close it. So the problem is, okay, yeah, so here we are now, and we have a number, that is a number. So okay, we'll keep it as a 1. Now we got another number, so like I say, we have the same number, or it is same, so we'll keep 1 as it is. And then we got another one, so it will be 1. So shall I keep them or what? Then I got 2, so 2 minus 1 will be, okay, no, we can't do this 1 2, otherwise we'll lose everything. So I mean what we need to do, first we have 1 and 1 and 1, we have 3 ones. Then we got 2, so if we got 2, then we will counter them. And then we got 1, so we'll keep them. When we got 2, we'll remove them, 1 will pop it from this array, and finally we will get 1. And I just want to see the corner cases. What if we have 1 1 2 and 0, so we have and 1, okay. So for example this one, so we need to keep both, right? And then 2, so we'll remove 1, and then we got 0, so we'll remove 1, and then whatever number we are getting left out, whatever number we have, that we will consider as a unique number, because all other numbers got count. Just counter, basically counter word will be incorrect here. So I'll say we got two different numbers and they cut each other, or maybe they just compensated, or they are basically, you can say one is if the numbers are opposite, or if numbers are not the same, then we can drop them. I mean these are the opposite genders, you can think of, like or maybe I'm not getting exact word here, so you can say yeah, those numbers can be crossed over, or maybe you can clear them. No, that's not correct word. So maybe you can uh, counter them, no, clear them, no. Okay, so I'm not getting exactly word to clear the numbers. But how I'm just curious to know how are we going to store the numbers that are same. So we have 1 first, and then we got 2, then we just pop 1. But I'm just curious here, could be condition like we are at starting we are getting numbers, so it's like you are going to use at max size of n by 2, uh, n by 2 plus 1. So that can be the maximum numbers, or it could be more than that. It could be uh, it, it can go up to order of n. Okay, because order of n minus 1, because maybe there are n numbers, and that is the size of n, and out of which only one is different number, all other are same. So it could be so the maximum size an array can take up to order of n. So I'm not assuming like here we need to take order of n size of array, otherwise it will harm. I feel okay, so we don't need to take this. What we will do, we'll just take count and we'll take the number. So yeah, that will help us. Count will be the total number of element, and number will be the number that is different number. Okay, so that way. So maybe let's start with this algorithm. The first example we'll take that one only. So we have 7, and we have 0, we have 0, we have 1, we have 7, we have 7, we have 2, we have 7, and we have another 7. So let me zoom it little bit. Let me zoom it as much as possible. I mean possibility is high. So at starting, count will be 0, and the number will be, let's say take count equals to 1, and first number will be num will be 7. Okay, we start with this number and we'll see, are you same as num? If not, then we can make the value as count as 0, and number we already it is. Okay, let me see the constraints first. What are the constraints here? Otherwise the problem is, oh, it's why it's running and it's so much heat my laptop is producing so much heat, and the reason for that is it's taking I always felt like when we are streaming it is taking so much of computation. I don't know why it's taking so much processing power. Bro, don't say I don't know. There are so many things happening, like behind the scene. For example, one is running camera, another is running screen, another one is running, another is continuously pushing data towards YouTube servers. So there is so much happening behind the scenes, and because of that it is taking so much computer power. Okay, so numbers can be negative as well, and it could be positive as well. So how are we going to check? Okay, so what we will do, now we have count 0, that means we don't have any numbers to check. So we'll get 0. If count equals to 0, then we take it as a number, and we'll update 1. Okay, great. So far we have covered this. So we have number 0 and we have count 1. Now we got another number that is not matching with existing number. That means we can again the count will be 0, and don't need to touch this one, because whatever number is we don't care about it until we have count. Then we are going to get 7, and we'll see, we'll again update to 1, and the number will be 1, and it will be 7. Okay, great. Now again we are going to get 7. So if it is matching, then we'll just update count, and then we got 2. Then what we'll do, we'll subtract 1, and it will be 1, because we got a opposite number, and the value will be 7. Okay, so we don't need to touch that value. And now we got 7 again, so value will be 2, and again we got 7, so value will be 3. Count will change. So that's how we are going to solve it. So I hope we have covered this, and in this way we don't need to take any extra array, or we don't need to take any so we are not going to use any space complexity. It will be if we are using any variables, and also those will just take order of 1. So we can say we are going to solve it. So let me say count equals to 0, and existing num equals to num is good, or nums of 0, so let me update the count to 1. So we have and now how many numbers can be there? 1, 2. Okay, for I, or let me say EL in because we are not caring about, or we are not processing index, so we don't need to use anywhere index nums of 1 onwards, because we already processed 0th index number, our first element. So yeah, so we will start with second element onward. So now if EL not equals to, will it work? Not equals to like this. Yeah, it will work like this. Not if count greater than 0, and okay, we will be having two conditions. If count equals to 0, let me first handle this. We have count equals to 0, that means simply we are going to do num equals to yeah, element, so and then count plus equals to 1, or let's say count equals to, let me be little more specific, count equals to 1, else that means count not equals to 0, if and if count, okay, if num of whatever number that we have equals to you can say the element, then we are going to say bro, it is matching with the existing number, then count plus equals to 1, else if numbers are not equal, that means count minus equals to 1. Okay, finally return, okay, num. Yeah, so that's all about the question, and I hope it will be easy and peasy. Let's submit it, and yeah, we already solved it, so yeah, it's great. And our algorithm, our time complexity will be order of n. So that's all about it, and let's jump to another problem. I hope it is clear now. Okay, now we are going to solve a problem that we have not solved in the past, so that is the great, and we will get opportunity to learn something new. So that is the positive aspect of solving a problem. Okay, let's begin without wasting our time. So we have a problem that is, the title of problem is next permutation. So a permutation of an array of integers is an arrangement, is an arrangement of its members into a sequence of linear order, okay, to be honest I did not get it. Like, yeah, permutation is basically arrangement of element of its member into sequence of linear order. For example, okay, for example, we have an array, for array 1 2 3, the following are the different permutation, following are all the permutation of array. Okay, basically we are all the possible combination of 1 2 3. So for example, it could be 1, and just we changed and then we changed 2 and 3, swapped their position, so it will be 1 3 2. And then what we did, we just changed 1 and 2, so it will become 2 and 1, and it will be 3, then 2 and 1 3, and 2 3 1, so this is another possible combination. Okay, and then 3 1 2, 3 2 1, so these are the possible combination. So I know how the people do it. Normally what they do, at first place, what are the possible combinations? Okay, here it could be, it can come like it here. Okay, we'll see it in the draw board. The next permutation of an array is the next lexicographically integer greater permutation of its integers, okay. More formally, if all permutation of array are sorted in lexicographical order, then the next permutation of array is the permutation follows in the sorted order. If such an arrangement is not possible, either the array is the last permutation, then rearrange it to the lowest possible order, either sorted in ascending order. Okay, so that means if not possible, then it is the last permutation of an array, and then we can say we are going to return the first permutation of an array. So how we are going to approach this? 1 2 3, so it will be like 1 2 and 2 3. So 1 3 2. Yeah, next permutation is 1 of 1 to 3 is 3 2. Example 2, 3 2 1. So 3 to 1 is already sorted number. I mean, it is the largest number that is possible with these numbers. So can I say that's why they just reversed? But bro, how are we going to approach this problem? Okay, let me see. So let me first note down the example. We have 1 2 and 3. Another example 3 2 and 1. Now let's jump to the whiteboard. Oh my bad, I just burped, and reason for that is I before I started the session I just do drink milk, and because of that like I got little burp. I just drink or drink. I just drank. No, I just drink milk. Drink. Uh-huh. Okay, so here are the numbers 1 2 3, and now we just need next permutation. It is easy to start, but it is hard to finish, and here we are. Okay, we have numbers, so can we say how are we going to derive it? So okay, we have these numbers, so can we say we have number like this 2 and 3. So that means whatever number that we have here right now. Okay, let's see, 1 we have 1 3 2. Bro, just I'm just getting little bit of essence of it. I mean, first we need to look up, start looking up from the back side of it, because we want just next number. So I know 3 is holding its strong position, so we can't get any number from left side to this location, and the number will be next, because these numbers are will make it a smaller number. Yeah, I mean, wherever the numbers are, these numbers are always, if these numbers are bigger, okay, if any of these numbers, if any of these are bigger, and if you change their position, then the number will be smaller. I mean, if you pull the, for example, it is 9, and if you will pull the 9 here and you will swap it with here, then it will be a smaller number. So we can't say we won't start with first number. We can't change it the first number. So what? Shall we start with this number? Okay, great. What are the possible options for this? So can we, if the number that is bigger than this number, let me say we'll take two positions, this number and this number, and we'll say, okay bro, are you greater than me? If it say yes, then let's swap with each other. So what it will do, it will do like 3 2. But what if this number, and let's say take example of another one, 1 3 2 4, okay, and now or maybe let's say 4 and 2. Okay, so first we will start with this number and this number. So it will say, bro, are you greater than me? So it will say, no, I'm smaller than you. So that means you are not going to help me. Or if I'll will swap with each other, then I'll get a smaller number. So let's move to next number. I mean, we can't do anything here, at least for the timing. Yeah, because okay, now we'll jump to this number and we'll ask, bro. Again, we'll ask from the first number only. Are you, I mean, greater than me? It will say yes. Okay, I am greater than you. So we can't swap these two numbers. It will be a smaller number. Okay, if it is greater than this, okay, that's great. So we'll ask again to next number. Are you greater than me? It will say yes. So we'll say okay, let's swap with each other. So 1 4 3 2, that will be the number, and we have to repeat it for all the numbers. And what is the size of an array? And the maximum size of an array 100. So can I say, okay, and just we need to tweak a one digit, and that is okay. We'll get the number. Okay, but I'm just curious. Do we need to I know we got an algorithm where what we are going to do. Okay, let me deep down. I mean, we have to think more about it. Let me take little more time so that we can think more clearly and in a proper way. So I'll give it 30 minutes. 0030. Yeah, let's take time and analyze the problem in a proper way. We'll see all corner cases. So for example, we have the number 1 2 4 3 2. Okay, leave it. I just took random number, but I'm looking for a good example. Is there an undo option? Okay, we have undo option. Okay, so at starting we'll take here. I know we can't directly change this number with any other number. The reason for that is the number will be always smaller if we are swapping with any other number that is in the that is before it. Okay, so we'll get a smaller number here. So that's why we can't change this number. So we need to check, or maybe we'll need to check with 3. Start with 3. So 3 2. Can we switch? No. Then we need to check with another number. So I mean, we can't place any number that is at the right side of it, and if it is a smaller number, so we can't do this. Okay, now let's check for 4. Okay, for 4, what will be the value? 4. Bro, can we say, I mean, I got one more thing here. What we can do, we can we can find the minimum number in the scanned array and max number. So min will be 2 and max will be 3, and we need a number that is greater than this number. Okay, but problem is okay, one more problem here. So far these numbers are basically whatever the numbers were before it, these are small, I mean smaller than this number, so we can't swap them. Okay, that means this is the largest number so far. And okay, now actually we need a number to swap, and that should be larger than, I mean smaller than these numbers. So if we see 4, can we swap this number with 4, 3 and 2? No, we'll get a smaller number. So far we have max 4 and min 2. Great. Now we need to check with this number, and we need to find out the smallest number, whatever number we have, smallest larger number, larger than this number but is smaller than in these numbers. So can we say which number is smaller than this, I mean greater than this number but smaller in the array? So if you see, we have 3. So 3 is the, I mean, but how we will make sure, I mean all time we need to scan the array. So it will be like, suppose there are 100 elements and we are looking for all the elements. So first time we are going to scan one number, second 2 number, 1 plus 2 plus 3 plus 100. I'm not good at it. I feel like it's 100 into 99 and 99, or 101, 100 into 101 by 2. Bro, is it okay? Order of n square taking time? I feel it bad. But how can we make sure? Problem is like we can't store, if we can't store min, we can store min and max, but what about if we need something that is between these numbers? So here it will be like next number will be 1 3 and yeah 3 4 2 2. Okay, and just I'm thinking more about it. So for the time being I'm just assuming like this is only the solution, but still I'm not quite convinced with the solution. And we're just thinking about what will it be correct if we'll swap these two numbers directly. Maybe I just took a few examples here. For example, I took, what if there is a 0 number and then 0, then it will swap with this number. So that means all the numbers before it are smaller, all the numbers before it are smaller, I mean smaller than this number, so all are in ascending order. And if we are swapping this number, so we need to swap it with the number, this one. So this number is basically greater than this number, so we are going to replace it, and this number we will place it here, or maybe we need to place it, what if it was 1? Then we will place with it this number. If it is 4 5, no, I feel like it will be completed. Okay, but just still I'm curious to know if we can solve it without using. So let me first try this approach and then I'll go to the editorial part. if it is not working. Even if it is working, then we are going to learn that new approach. But before that, I'll try to solve using this approach only. So I think there will be two loops. So, and we'll use flag. Flag is nothing but false first. Okay. So, okay, for while okay. I mean, so what we will let me note down it first. I'm not going to solve it directly here. So we need a loop. Great. And we need to point to all the elements from right to left. So can we say j equals to n minus 1 or n minus 2? That will be the second element. While j, we need to change the color. J equals to n minus 2 greater than equals to 0. So for particular j, let me start with here. And now we need to find out any element in the in the array that is just greater than this number. So for I equals to this is not a, so let me do one thing. J plus plus, no, we need to do j plus equals to 1 here, and for rdx in range, and here we will be having from 0 j will be whatever the value of j is there, and we are going to get it from j plus 1 till n minus 1, all the numbers. And if rdx array of rdx is greater than so we need to take one more, min idx, that will be minus 1 at in starting. Okay, and okay, so here if array of index, that means that particular number is greater than this number, greater than the array of j. Okay, so min idx will call it as a min idx will be nothing but this number. And here we will do one more thing. If min idx, if it is equals to minus 1, that means simply do min idx equals to idx, else min idx will be min of Oh, bro, there will be one more problem. So this is one condition, and else if, okay, sometime I feel like if area of IDX is, that means that particular index number, okay, okay, I got it. No, I didn't got it. First we'll look for a smaller number than this, so maybe we got 3, then just larger number than this. But what if, okay, I'm just formulating, maybe we have 2.5. If I'm just taking example of 2, and here maybe we have 3, we have 2.5, I'm just assuming. So 2.5 will be the most preferable candidate as compared to 3. So we need to reduce the mean value, or maybe need to update the index. So for that I'm just checking if array of IDX is greater than this, that means yeah, it is greater than the array of Z. Okay, that means, okay, if array of IDX is less than array of uh, min IDX, that means we need to switch the min IDX to this number. Min IDX will be IDX. Okay, so we updated the IDX and J plus plus, so that will be going to happen. And finally, so this is the condition to check back. And now if this is not the condition, then what we will do? Okay, here we can change flag to, no, let's not change. Finally we have the number, and we find the minimum index, and now we can say, okay, uh, swap the numbers, swap numbers, and also make flag true. And so this is completed, this one, this part, and break loop, because we got the number, smallest number. And if flag is not true, then just sort the number, uh, basically reverse the number and get the, no, not so, I mean sort the numbers and get the result. Sort and get. So I'm just curious to know more about it, like how exactly they are solving it, so that we'll get more about more information. Min IDX is equals to -1. Let's take that is nothing but the index we are just take. And now let me take one more I mean J equals to 0. Now let me take one more variable, n equals to, that will be the length of nums, or the size of array. So can we start with the last index? So last we don't need to take care, because that is the already smallest number, and we do not have any number preceding to it, so it will be most preferable numbers. Or maybe we can't get any number just larger than this number from backside. So yeah, so with the one number we can't swap it with anything. So okay, now we need to change, so that's why J will be n minus 2. Okay, and while Z greater than equals to 0. Okay, great. So for I means IDX in range, and it will be J plus 1 to n minus 1. or we'll say 1 n, because n won't be included in it. And now we have numbers. So if array or nums of idx is greater than the number exactly, I mean the don't take pause, bro. So if it is greater than the number that the number that we have at the index j, that means it is a uh, uh, feasible candidate for it. If min idx equals to -1, simply store it min idx without checking anything, so it will be idx. But else, if okay, else if min idx, I mean there will be two scenarios. If nums of idx is greater than nums of j, okay, great. But if okay, in nums of idx is greater than nums of j, wow. And just we need to check if nums of idx is smaller than nums of okay min idx, that means this number is smaller as compared to the last one. So min idx will be idx, and okay, that's great. Finally, if min idx not equals to -1, that means we have something to swap. So then we can do one thing, flag equals to true, I mean it will be used flag equals to true, and okay, and now we can break the loop. But before breaking the loop, we need to swap the numbers. So swap I mean, yeah, we can't swap like this. So nums of j and nums of min idx will be swapped with let me try copy them again. Just flip the location, flip the position of these numbers. So it will be something, it will be like, first it will be the first num of min index idx will be, and the second number will be nums of j. So great, we swapped the number. Let me write swapping, swap number, okay, swap number, great. So we did this, and now finally if flag equals to true, I mean we don't need to use even true. If flag, that means return nums, else return, I'll use sorted here for the time being, or maybe nums dot sort, we will use simple pattern sort, and it won't return any value, I believe. So okay, let me do one thing, we won't return this, so we'll do this nums dot sort, it will sort the numbers in place. So if we are using nums dot sort, it's going to perform the operation in place, I mean it will modify the existing array. So then finally we can return nums. Why I remember this? Because few days back only, when I was solving the problem, I found like it is returning none, so you can't return none. So then I realized, okay, maybe these nuances I am not aware of, but once you are practicing and you will get it. But before that, we need to check whether it is working or not. Did I made any mistake? Yeah, you know what, and let me tell you, we haven't done any. It's going to take j plus equals to 1, if you remember, and it's going to perform the operations for infinite time, or what? Is it still working? I mean, I'm really sorry for it. J minus equals to 1, it is going to increase, and it will be like time limit will exceed, and okay, we are able to solve it, but I'm still not so convinced, and it got wrong answer for test case. Wow, that's fair. Nums your output through 231, expected 213. Wow, great. Let's see what is the problem in our exam solution. Actually, we are just here to experiment and learn. So yeah, maybe I'm my thinking. I haven't thought about all corner cases, so we'll get to know. 231. We have a number. No, we have 132. I mean, great. We have this number. So initially, as per our algorithm, it will be the same. Won't we are not going to check. So we'll start with this number and we'll say, bro, can we switch these two numbers? It will say, yeah, we can switch because this is the number 123. Okay, so we need to swap these two numbers, but as per our algorithm, how it's going to perform, uh, j greater than equals to 0 and j will be n minus 2. So n is nothing but 3 here. 3 minus 2, that will be 1, and 1 is nothing but this index, so 0 1 2, so 1, and we are going to start performing for idx. So j is 1, and now we need to look for the numbers from j plus 1 to n. Yeah, so j plus 1 means 2 to n will be here, this number. If nums of idx is greater than nums of j, why we swapped 231? I'm just worried about it. I mean, what kind of mistake we made? So 231. Okay, first we need to check if the number is smaller than this number. So we'll see. Let's see if num of idx is greater than, okay, so here we don't have greater than number, so it will jump to this number here, and we'll see. Okay, okay, got it. 2 3 1. We just assume that this number is the right location of it, because this is the, but if you see, man, completely whatever I assumed, it failed. I mean, my thought process was wrong or what? Let me see what was the wrong with the algorithm. 2 3 1. I assumed this, so I thought maybe we need to swap those two numbers and it will fix the problem, but here I can see we have now 31. So if we are updating any number, then all the numbers before after it should be smaller one. So can we say we need to sort all the numbers 1 and 3 and 2? But bro, if we are going to sort, then what's the purpose of it? I mean, really, I know I can solve it using, wow. So yeah, it is. Now just let me think more. How many minutes, bro? I just completed. I mean, 30 minutes. I came up with solution, but it failed. And now I need literally I'm confused. What should I do? I know after swap we can do one more thing, like all the numbers after it can sort them. So sort the number and get the result, but it will be a challenging part for at least for me. I mean, so here we are just looking whenever we are swapping a number, we are just looking in the array, and we need to get the number that is uh, just greater than this number, greater than this number. Okay, so we can get that number by just comparing the numbers and checking uh, with all the numbers whoever are. But the problem is we need to swap all the numbers. I mean, yeah, so number that we are going to swap. If we are taking 1 to this number location, and now we need to check the location of this number perfectly in the number. What are you saying? No, it's not working. I mean, literally. Let me try that approach, but yeah, I feel like it's not right approach, but okay. So after sorting it, no, I feel like it's unethical. I mean, I don't know why I feel it like. But now approaches to solving this problem is to generate all possible. Okay, let me add 20 minutes time as more. So total we have spent time, I mean, more than 40 minutes, and now we again ask for 20 minutes. So bro, it's literally devastating time I'm taking it for. Let me first read the editorial, and then I'll watch if necessary. I'll watch the tutorial as well. So a straightforward but naive approach to solve this problem is to generate all possible permutations, okay, of the given array. Once all permutations are generated, we sort them in lexicographical order and perform a linear search to locate the current permutation, the next permutation in the sorted list in the return. If the current permutation happens to be the last one, we simply return the first permutation from the sorted list. To generate all permutation, we use backtracking. Okay, that's not going to help us. I mean, it's literally going to take lots of time and computation power. You are going to generate, like, basically you are going to calculate all the possible combinations. So currently we are not focusing on it. Space complexity, time complexity, I mean, n factorials will be different operations. So, and every time we are going to perform an factorial operation, so n into n factorial, where n is the size of input array, and to generate all factorials exploring n factorial arrangements, so order of n. Space complexity, recursion stack can take order of takes up to order of n space, and storing all permutation order of n into n factorial. Is an STL function. So uh, what we call it is STL. I forgot the name of standard template library. Yeah, but optimal. Okay, there are two toggle buttons. Great. To find next lexicographical permutation in array, the key is to make the smallest possible change that result in a larger arrangement. Okay, the process begins by identifying a position in the array called pivot, where the value is smaller than the value immediately to its right. Bro, sometimes the terminologies are very complex. I mean, to find the next lexicographical permutation of an array, the key is to make the smallest possible change and change that result in a larger arrangement. Change that result in a larger arrangement. Okay. The process begins by identifying a position in the array called the pivot where the value is smaller. Value is smaller than the value immediately to its right. Value immediate to its right. Is it true? I mean, literally. Can we say it? Let me say 1, 2, 4, 3, 2. So we need to find the pivot where values is just this number. Yeah, so yeah, true. Basically that number is nothing but where the okay, so the same concept they are also calling, but yeah, they are using proper terminology and they come up with the theory like where this number is, I mean, greater than the number just immediate to it. I mean, that number is possible to swap with this number. Okay. This breaks in descending order indicates where an increase in permutation is possible. What do you mean? This breaks in descending order indicates okay, that means all the number before it are increase descending order. This breaks in descending order indicates where an increase in permutation is possible. Where an increase in permutation is possible, the pivot is the point from where the array stops begin in when scanned from right to left. Okay, once the pivot is found, the goal is to make the next permutation just slightly larger to do that this scan from the end again, so to find the first number greater than pivot. Okay. I like it. I mean, really, I thought too much about it. I mean, just we need to scan from the last to the starting. Bro, why can't I think about it? Yeah, so if we'll scan from this number, we'll say, yeah, this one is not equal. Then we say this number is not equal. Okay, till now it is okay. Swapping these two values ensures the ensures the increase in the number is minimal. After the swap, the portion of the array after the pivot is still descending order, which is the highest possible order of those elements. Yes, because we swapped with the smallest possible, and to obtain the smallest possible suffix, this subarray can be reversed so that the elements are arranged in ascending order. This guarantees the next immediate permutation in lexicographical order. Bro, really I feel bad about me. Like I just solved, I just completed it. I mean, I just developed an algorithm, but I wasn't able to formulate it in a proper way, and I did lots of garbage code here. I'm really feeling like, yeah, at least was able to do it, but not in a proper way. Okay, great. But I got to learn new thing. So that's shout out to the team who wrote it. And yeah, so for the timing, what we will do. So first thing is, let me note down the example. It is easy now. So we have, okay, great. Yeah, I'm happy for it. Like I'm learning something new. Whatever is the way. I'm taking time. That's okay. I'm learning. 1 2 4 3 and 2. Great, we have these numbers. Now we know this number. If this number is we are looking for number that we can swap. So we'll see this number. This number does not have any immediate next number, so we are going to start from scanning from this number. Bro, do you have any number which is just greater than you? It will say no. We earlier, what I was doing, I was scanning to all the numbers, but I feel, I haven't observed that pattern. Like here all the numbers are increasing only, that's why we are unable to sort them. We'll check for this. Is there any number that is greater than, I was scanning here all the numbers, whether if to check if there is any number that is if there is any number that is greater than this number. Just not lust, bro, it's just greater than this number. And I found no, this one is greater, this one is greater, these are a smaller number. And then we moved to another number and we found, oh, this number is greater than the number that is immediate to it. All the numbers are descending in nature. So now we just need to find out, like we need to start scanning from this side, and we need to find out any number that is basically, that is nothing but basically the number that is greater than this number. And for that we need to start looking from this end. So we'll check this number. If it is not, then we'll check this number. If it is, then we'll just swap it. Okay, so wow, whatever I developed the code, it was working and it is working. But let me first do it with that approach only. So we'll solve using this only, and then we swapped the number, and then we'll develop this, we'll clean up the code. But first let's solve it so that we say it is still the relevant number. Okay, so let me develop a function that will be reversing the number, that is going to reverse the number and will pass the index. So define reverse, I don't know, self, and then nums array and start int. So these are the index, and here what we are going to do. Okay, so from start we are going to, okay, let me do one thing. I equals to start and j equals to end, and while I less than j. Yeah, if both are equal, that means no matters. So basically nums of I and nums of j will be nums of j and nums of I. Okay, so we are swapping the numbers, and then I plus equals to 1, we are moving towards right, j minus equals to 1, we are moving towards left. And that's all about this number. And finally we are going to return. Do we need to return nums, or it is okay without nums? It is just passing the, we are passing reference. So let me do one thing. No, we don't need to return, I believe. Okay, let's try without changing it, or without making any change. So here we have numbers, and now I can see, wow, what is wow here? So we swapped the number and we found the mean index not equals to -1. That means we swapped that particular number mean index with the j. So after j onwards, reverse numbers self dot reverse. Okay, let me use this number as input and we'll check. Oh wow, failed test case already added there. Great, bro. I mean, they did something really appreciable. Yeah, we can appreciate them if they designed it in a proper way. They are trying their best. Shout out to them. Thank you so much, guys. Self dot reverse and nums, and here will be j plus 1 because j is the right number where we swapped, and onwards till n minus 1. Okay, so great. Here we are doing this, and I think now we don't need to use sort. Instead of that, we can use self dot reverse. Will it work? We have the largest number. I mean, that means all the numbers are in increasing order. Okay, so reverse will work here. We'll get the smallest number, so we'll just reverse. So nums of and then 0 to n minus 1. Okay, great. And let's see if everything is working, then we'll submit it. By God grace. What is the meaning of God grace? Oh my god, it failed again, and this time I'm just little problematic. I feel, bro, I can't debug this problem. What if I'll use sort here? Let me see. Nums dot sort. Okay, let me use this test case as well. Okay, great. We are failing. 35, 45, 87, 49, 72, 60, 72, 63, 60, 74, 90, 42, 90, 42, 47, 50, 69, 12, 50, 69, 12, and then basically to after 12, 45, 10, 30, 61, 6. Bro, is it the way? 55, 9, 96, 89, 43, 5, 5, and 83, 66, 6, 78, 63, 59. Oh, though it's a big number. I won't be doing this. And now I'm just worried about it, how things went wrong. Let me do one thing. Bro, so -1. if nums of I, Aya, what went wrong? I'm feeling worried about it. Wow, how I'm going to debug this big number. It's very problematic. I'm able to solve it for smaller problems. Let me see the code there. Or let me do one thing. Shall I drop the idea of solving this number today and maybe we'll solve it later? But bro, I will solve it. Then I'll like log off after it. I mean, I'll just shut down the stream, but before the time I need to solve it. So we have z n minus 2. Okay, great. Okay, let me do one thing. Okay, I'll do one thing. Bro, it's very difficult to debug this. Oh, what I did? Maximize it. So for I in range n minus 2, that means the second number starting minus 1 means starting number till minus 1. If nums of I is less than nums of I plus 1, next immediate number, then index is equals to I and break. Okay, means we got the index of number, way that number to be swapped. Wow. Let me do one thing. I'll comment all everything, and now while z greater than equals to 0, we'll use our own, and if nums of z, that means the existing number, is smaller than nums of z exit z minus nums of j minus 1, I mean the number that is just immediate to it. So okay, when j plus 1 will be there, I'm like now I'm just making mistakes similar to I'm just looking at, like I'm just trying to copy the code or what. Yeah, so that means that is the index. So let me say it as a idx, not idx is nothing but here it will be minus 1 and here it will be idx will be, okay, what it will be, minus 1. I mean okay, idx will be z, and we need to break loop. If idx equals to minus 1, that means we don't have number return. Self dot reverse, we are going to use our function. So nums and start int. Okay, perfect. But it won't return anything, right? Okay, so let's say it like this and return nums. But if this is the condition, else what we are going to do, we need to find it the number, greater number. So we'll start scanning from the end and any number that is, so for let's say rdx or el, no, rdx in, let's say I, because rdx we use I in range. Okay, so n minus 1 to 0, I mean minus 1, then that means we will use 0, and -1. Okay, so we are using backward direction, and if nums of I is just greater than I, if greater than nums of I dx, that means this number is greater than this, so we can say we need to swap and we need to break. First thing, we don't need to process any other number, and nums of I comma nums of I dx both will be swapped, and nums of I dx and nums of I will be swapped. Okay, so we swapped these two numbers. Still I'm not getting why my code wasn't working earlier, why haven't worked, but I need to debug more on it. But for the time being, let's break it. Let's, and now we got the number, so we need to check, or we need to self dot reverse, and we can say here it will be something like we need to pass nums, and then index will be from idx plus 1 and till n minus 1. So yeah, all numbers should be swapped and then return nums. I feel it should fail. Oh, what I made mistake. I know, I always forget when I'm doing, like, I'm performing loops, j minus equals to 1. That's why for loops are far better than this while loop. We need to manually it worked. Why you always do this, bro? Start will be 0 and end will be n minus 1. Oh, okay, it solved the fourth one as well. I'm little unhappy with the solution. I mean, what went wrong? Okay, let me do one thing so that I can sleep peacefully without any headache and all. I'll ask, maybe why should I ask ChatGPT? It's a very bad habit until. So okay, we have two things now. I mean, reverse is working perfectly. So only problem is, I believe, for the fourth, what will be the index? So I just wanted to know. I mean, yeah, for fourth, bro, where is the fourth one? Print idx. So let me see what will be the value in the last one. I'll debug it. Logs 75. Okay, great. Now let me see what will be the value of here. What will be the value here if I'm using it? So now sometimes it's very good to know and debug problems, but like at what cost? That is also problematic here. I mean, yeah, literally. J, what is the value of J here, and J I mean min index not equals to -1, then wow, we are doing this. So let me print min index. $76. What happened to you, bro? Why you printed 76? There we were getting 75. Let me debug it. For idx in range 0, range j plus 1 to n. Hey, why I printed min index? I had to print j, right? J is 75. But why min index is greater than this number? I'm little curious about it. Bro, literally. Print C and print min idx. Let me see how it can be more than this index. That's where the bug is. For idx in range j plus 1 to n, if nums of idx is greater than nums of j. Okay, min index -1. Okay, nums of idx is greater than nums of idx is greater than nums of j. Okay, means the number is greater than this number. So we have started scanning from j plus 1, j to j plus 1 to n. Okay, I mean I'm little fool or complete fool or beautiful, I don't know. If min of idx is greater than nums of j, then it means if min of idx okay, so we have j that is 75, that is correct, but problem is here we are getting min of idx 76 and what we were getting there let me print also the value of min of not min nums of j and nums of, but bro it is tukka. I mean just you are guessing or what? Debugging like 75 4 number is 7 26 7. And what about it if we are using this number? I mean I'm literally tired now with this all bullshit. I have to go gym tomorrow. I don't know. bro, literally. 477. Okay, okay, got it. I failed. Less than equals to min index. Then we need to swipe it. I think now it will work. I mean, if the number is smaller in past, a small mistake can make you dumbest person or what. Now it accepted. Finally, I mean, I just debugged the problem and I found my code has one bug, and that was like I was considering the larger index, but we are looking for we are looking for number that is smaller, and we need to switch with that number. But how it's going to help if the number are equal? Then min index and all, leave it, bro. So I feel like I just solved two problems, and within the almost it's 1 to 1.5 hour. No, almost it's 2 hour, and bro, we just finished two problems, so it's very bad. Okay, no problem, we'll solve two more, or maybe I need to work more on it. Set matrix 0. Okay, so for the timing, that's all for the day, and we'll meet tomorrow again, and tomorrow we'll target more problems. And yeah, that's all for the day. Thank you so much, guys, if anyone is watching till here, and bye bye. Have a great day, and wishing you all the best for your journey wherever you are and wherever you are wishing. May God fulfill your all dreams and wish you best. So boom bomb, and here we go. Let me stop recording.